Stand by for adventure.
With conventional fuel rockets, it would take 16,000 years to get to the nearest star. Conventional kind of rockets are just out of the question for interstellar travel. You're going to have to do something a little bit more out there.
Slow to half impulse.
Wait, 1/2 impulse.
What we're trying to do is build an impulse engine like you hear on Star Trek. We'd like it to go at about 0.4 the velocity of light, just so that we can get to the nearest stars within a human lifetime. There's no burnt up fuel, there's nothing being shot out of a tailpipe, and it's the gravitational field that actually will propel this thing forward.
This is the Mach Effect Gravity Assist Drive, a device that could make interstellar space travel possible. But the Mega Drive, as it's known, is also a design that hinges on some pretty controversial physics.
For many years, you work on a project that people think is nuts, and you're likely to be regarded as nuts too.
Now, after 30 years of fine-tuning, this pair of scientists might finally be close to getting the results they've been hoping for. And NASA are taking the idea seriously.
If something like that were true, it'd be earth-shaking. It'd be groundbreaking, revolutionary new physics. But those sorts of advancements don't come along very often. That would be a pretty extraordinary claim to say that we've put this new spin on the way the universe works that we didn't know before.
It's a well-known Newtonian law. An object at rest stays at rest, and an object in motion stays in motion at a constant speed unless an external force acts on it. All objects resist a push to some extent. And what makes them do that? Inertia. In the 19th century, Austrian physicist Ernst Mach made a conjecture that these forces of inertia result from the gravity of objects in the distant universe. It became known as Mach's principle, and while most experts have now dismissed it, scientists at this lab in California think the idea is just misunderstood.
Mach's principle itself has sort of gone out of vogue, and people don't seriously even discuss Mach's principle anymore. It just depends on the way you think about it. If you look in a textbook, you might find 5 or 6 different definitions of Mach's principle, but the one I'm thinking of is that distant matter way out there can influence things up close.
To get your head around it, take this old analogy used to illustrate how matter bends space-time. If you put a heavy object on a trampoline, it falls in and curves the rubber sheet. Now, if you roll a ball on the trampoline, it will keep orbiting the heavy mass in the center. That's how a planet behaves when it's attracted by the gravity of a star.
The thing is, for the rubber sheet to act that way, it has to be under tension, it has to be stretched. And we're saying that basically the distant matter of the universe is what's pulling the space-time and making it taut, and that's what's causing it to act basically like a rubber sheet.
The stretched rubber sheet is loaded with potential energy, and according to the team's understanding of the Mach principle, so is space-time.
So we're thinking that there's a big gravitational potential out there, and this device can actually tap into that. Imagine the space-time of the universe as being like a very, very flat lake, and you're sitting in a rowboat, the kind that has the seat that moves backwards and forwards, but you don't have any oars. Instead, you have 2 great big buckets, like big trash cans.
While you slide forward in the seat, the mass shifts around and the boat moves slightly. That's conservation of momentum, another Newtonian law. If there are no external forces acting on a system while it's moving, its center of mass has to stay in the same spot. And so the boat is moving to compensate for the different distribution of mass.
And what you're going to do is you're going to dunk the buckets into the water, which is the universal space-time. And now you're a lot heavier than you were. Now you're going to slide back in the seat. And as you slide back, the boat is going to move under you so that your center of mass remains in the same spot. The boat actually moves forward as you slide back in the seat. Then you can dump out the water, you don't need it anymore, and then you repeat that process.
The Mega Drive works in a similar way. The part which is doing all the work is a stack of piezoelectric crystals, the same kind of material that's in your electric toothbrush. When you apply a certain frequency of electric current, the crystals expand and contract, which causes the whole device to vibrate. But the Mega Drive is set up to vibrate mainly in one direction, which causes it to accelerate slightly. The team says this acceleration enables the device to tap into the gravitational potential of the universe. By borrowing some of its energy, the crystals change mass and the device starts behaving like our rowboat.
That mass change is what's causing the propulsion, because each crystal kind of moves in this sort of fashion, so the whole stack is in this breathing mode which moves backwards and forwards. As it gains energy, it increases mass, and then it shrinks again and loses mass. If you time it just right, you can actually make that thing move forward.
All of this has been the life's work of Jim Woodward, who set off on this path over 3 decades ago. Since then, he's been working alone on the Mega Drive project in his spare time, until his desk at the university was relocated to the office of Hal Fern.
I was away on sabbatical, and I came back, and there he was. So
There I was, and Hal was not happy.
And at first I thought it was absolutely insane. I thought, what on earth is this guy trying to do? I took a closer look at what he was doing. That's when I really became more interested.
The shift is very small, though.
The shift is not that small.
I grew up on Star Trek, and I would love to be able to say that I worked on something that would help people get across space-time quickly. If the theory turns out to be correct, and we are really tapping into the gravitational field, it would be a serious breakthrough. It's just I've got to prove it. Hi, Shell, are you there?
But proving this idea has been a problem. The movements of the device have been extremely small, not large enough to register with the naked eye. But after receiving 2 grants from the NASA Institute for Advanced Concepts, or NIAC for short, the team has managed to greatly improve their existing prototype.
Jim was basically paying all this out of his own money. He must have put $30,000 to $50,000 into this project. He didn't want to buy off-the-shelf kind of equipment, because some of it wasn't available when he started doing this 30 odd years ago. You couldn't buy some of the equipment, you just had to make it and build the circuits yourself. We did have some people come over at one point, and they saw Jim's homemade boxes. They didn't really take him that seriously. I had to convince Jim to buy some equipment off the shelf that we could get fully calibrated.
Trying to get things set up so that we could actually do some runs that would make interesting video material.
Many new collaborators have joined along the way, and the team has designed a new setup for the device, hanging it from a pendulum to increase thrust and eliminate any vibrations which might be mistaken for it.
Okay, here we go. 3, 2, 1.
And they've finally started seeing it move with their own eyes.
You can physically see this thing shudder around vibrating, and you can physically see it move off to one side. So that's actually quite exciting. If we can actually show that by video, then I think that should convince quite a few people.
It's on a reflector on the frame, okay?
I still think we should give Jim that ear horn that looks like a wormhole.
No.
So I think it looks cool.
Yeah. The devices we build now produce those type of forces between 100 and 1,000 times larger than the forces that we were producing even a year or 2 ago.
It's very, very small. If you think of maybe a little pulley with a little mass held on the end of a string, the force that would produce if you drop, say, 2 or 3 grams of weight down, you'd almost barely feel it in your hand. It's almost like the weight of a feather. Maybe a little bit more than a feather, maybe 2 feathers. I'll be generous, I'll give you a couple of feathers.
The team calculates that the smaller the device, the larger the force it can generate. So instead of scaling up, they hope that arrays of thousands of tiny mega drives powered by a nuclear battery could one day be deployed to accelerate large probes into interstellar space.
They are sufficient actually in and of themselves to make it possible to take a starship, a human crewed starship, to nearby stars and back in some reasonable fraction of a human lifetime. So the question is, have we all screwed up? Are we collectively smoking something? Do we not know what we're doing? I suppose you might argue that that's the case, but the way to find out is to find out whether or not the gizmos that we make are really doing what we say they are doing.
A few other teams have already tried to replicate the Mega Drive's results, but the findings were negative.
People don't expect this thing to work. It sounds so bizarre. There are several things that could happen that could cause these false positives, and that's what people think is going to happen. If they're saying this strange effect is actually real, then and then somebody else comes along and proves it wrong, then they look like they have egg on their face, basically. So it's much harder to say that something is a real effect when it's controversial.
Because of this controversy, NASA is now funding an independent study of the Mega Drive at the Naval Research Laboratory.
The neat thing about the claim here is they say there's some revolutionary new physics that lets you vary your inertial mass, which means you can actually be heavier and lighter at different times. And if you can wiggle at the same time as you're changing your mass, now you've maybe got a way to move yourself around and do some sort of wiggly thing all through space. Now, is that possible in this universe? Maybe, maybe not.
Mike McDonald is part of a team testing the device, but even he admits that conclusively proving or disproving this theory won't be easy.
Is a test going to be conclusive? Let me answer that question with a question. What if I ask you to prove to me that there are no pink elephants? Now, you might say every elephant I've ever seen is gray, but how do I know you just haven't looked hard enough? The answer is that you can't really prove a negative. Tests give us enough information to decide if the way we think the world works is valid enough for us to keep going in that direction. And that's what this sort of test can tell us. If you ask me to put on my betting hat and say, are we really going to see exactly the effect that is claimed, and is it going to be so strong that we think, yes, it's definitely the mechanism that's claimed too? I'd say that's a number probably somewhere between 1 in 10 and 1 in 10 million, and I would lean toward the higher end. The odds are on no, to be honest, but the odds are on no for every new idea that comes up. And remember that science isn't a tool that gets dirtied by use. The scientific method comes out of any encounter looking as shiny as where it started. And if we use it well, even if we don't find that there's some new effect here, we'll learn something about how to do these kinds of tests better in the future for whatever is coming along next.
There's a small but real chance that there's nothing to it. For me, it's exceedingly unlikely. But there's been more than one occasion where things haven't gone right on a particular day, and I've started drafting an apology to the people who are interested in this, saying, gee guys, I'm really sorry. It wasn't real after all. I haven't had one of those episodes in a number of months.
Assuming the device passes its replication trials and nothing else can explain the forces the team is claiming, one day the ultimate test would be for an array of Mega Drives to maneuver a CubeSat in space.
I'm 79 years old, so I don't know how long I'm going to live. A few years, maybe I'll see something in space, maybe I won't. If I live longer than that, I'm pretty sure I will see something in space. Science fiction will be vindicated as transformed into scientific fact in that regard.